Hi everyone. So in this video, I want to go ahead and review the concept of dimensional analysis. Now I know it's been a little bit of time since we last talked about it, but it's really, really important in chemistry. It's one of those foundational skills that we're really going to need to have nice and strong before we get to our next topic, which is stoichiometry. So let's go ahead and spend a little bit of time reviewing this. So the first thing you should do when solving dimensional analysis problems is to underline the given. Now, the given is really important for two main reasons. Number one, it's what goes in the first box on our dimensional analysis or factor label table, so we will need that value. It's also going to determine the number of sig figs for our answer. So if we underline that, it just kind of helps us to make sure we're on the right track and remember that key information. The next thing that I recommend is that you circle the unit for what you are trying to find, okay? So that's the unit we're going to try and get to for our final answer. So with dimensional analysis, we use something called conversion factors to relate different units of measurement. Now, there's a ton of different conversion factors possible. We know things like 1 dozen is equal to 12 objects. In chemistry, we've also talked about things like molar mass and the mole. So Avogadro's number tells us that 1 mole of objects is equal to 6.02 times 10 to the 23rd. So those are some other conversion factors we can use. Next, we want to set up our factor label table that we use for our dimensional analysis so the units cancel on the diagonal. So what you have on top, you need to have that on the bottom of the next section. And then finally, when you solve your dimensional analysis problems, you're going to multiply across the numbers on the top and then divide by the numbers on the bottom. So let's go ahead and try this out with some examples. A runner competed in a 5-mile run. How many feet did she run? So one hint that we're given is 1 mile is equal to 1,760 yards. So these numbers, although they are helpful, are not actually part of the problem. They're just extra information I'm giving you in case you don't know how many feet or yards are in a mile. So the first thing I want to do is I want to underline my given, which in this case is 5 miles. So we want both the number and the unit. So 5 miles. Then we want to go ahead and circle what we are trying to find, which is feet. Okay. So now if we start to set up our factor label table, so remember we draw that horizontal line, and then our given is going to go into the very first spot. So that is going to be 5 miles. Now remember, when we set up our factor label table, we want our units to cancel on the diagonal. So whatever unit I have up top, I want the exact same unit on the bottom. Okay, so maybe you remember how many feet are in a mile, and if so, this will be a little simpler problem for you. But if you don't, we're going to use this hint. So we are told that 1 mile is equal to 1,760 yards. Okay, so that is my first step, but I'm not to where I want to go yet because I want to get to feet and I have my answer in yards currently. So I need to take this one step further. So if I have yards up top on the diagonal, I need the same unit. So yards, and I can go from yards to feet because I remember that 3 feet is equal to 1 yard. You can go ahead and cancel those out. Now, when we solve this problem, we're going to multiply the numbers on the top together and then divide by the numbers on the bottom. Okay, so we're going to take 5 times 1,760 and then times 3. Since I just have ones on the bottom, I don't need to actually divide by anything in this case. So this runner traveled 26,400 feet when they ran that 5-mile run. However, we do need to still think about sig figs. Now this problem's a little bit funky because we only have 1 sig fig in our given. Usually it's at least 2, if not 3 sig figs. So this one means I'm going to do a lot of rounding. So in this case, 2 is significant, so I'm going to kind of get rid of the rest. 6 is greater than 5, so I need to round this number up. So instead of being 26,000, I'm going to say that they ran about 30,000 feet. Okay, so that is what I would actually report as my answer. This has the correct number of sig figs. which is the one. Trailing zeros never count unless there's a decimal point, which I didn't write one in this case, so there's only one sig fig in that number. Okay, so let's try a more chemistry-specific example. If I have 27 grams of helium, how many helium atoms do I have? Well, as always, start by underlining your given, which in this case is 27 grams of helium. And then I want to circle what I'm being asked to find. The number of helium atoms. Okay, so I'm going to start to set up my factor label table. My given, the thing I underline, always goes in the first spot. So that's going to be 27 grams. It's going to go right there. Okay, now if I have grams of helium up top, I need grams of helium on the bottom. So now if I think about this, grams to number of atoms, I don't have anything that directly relates those two things. But in chemistry, the central idea is always the mole. So I can go from grams to moles, and that uses the conversion factor of molar mass. Now, since it's just a single element here, I'm talking about helium, it's really simple. I just look on my periodic table, I look up its mass, and I see that for helium, every 1 mole weighs 4.00 grams. So now I have moles, but I want to get to the number of atoms. So again, on the diagonal, I copy my units so they're the same. And then to go from moles, the number of atoms, I'm going to use Avogadro's number. So 6.02 times 10 to the 23rd atoms of helium. Okay, and that's per 1 mole. So that's Avogadro's number there. Okay, so as we look at this, numbers up on top, we multiply, and then we're going to divide by the numbers on the bottom. So as I plug this into my calculator, I'm going to take 27 times 1, which doesn't change anything. So times 6.02. And then to get that scientific notation, I type second EE23. Okay, so that's multiplying the numbers up on top. And then we divide by what's on the bottom. So I'm going to divide by 4. Try that again. So take my answer, and then I'm going to divide by 4. Okay, and then divide by 1, which doesn't change anything. So if I go ahead and write this down, my calculator spits out 4.0635 E24, but that is not proper notation when you think about sig figs, and we need to put it back into scientific notation. So this E24, that takes the place of that times 10. So I'm going to go ahead and rewrite that. And I also need to think about the number of sig figs. So from my given, I see I have 2 sig figs. So that means I need 2 sig figs in my answer. So I'm going to chop my answer off after my 0. Again, 6s are greater than 5, so we round that up to 4.1. And then the E24 becomes times 10 to the 24th. And finally, we're going to add on the unit. Atoms of helium. So I hope that helps. If you have any questions on dimensional analysis, please go ahead and let me know. As I said, this is going to be really important for this unit. So if you need any help, please reach out. Otherwise, have a great day, everyone. Bye.